Welcome to Spring LIB.
This problem, we have a mechanism shown to raise a crate of supplies from a ship's hold. So it's basically just a pulley here with a crank. And we're going to assume that the force acting on the crank is always perpendicular to the lever arm here. So that we just have the torque is the length here crossed times F. The payload here weighs or has a mass of 50 kilograms. The radius of this pulley here is 1/4 of a meter, and we're given its mass moment, and that is 2.9 kilogram meters squared. The length of this handle is 0.12 meters, and we want to have this payload, let's see here, we want to crank it so that the payload here accelerates upwards at 1.4 meters per second squared. So we have free body diagrams here, force acting on the crank and the force holding the pulley in place. I didn't label these because they didn't ask us to determine those, although we could. Well, they would be varying as obviously this crank goes around and this force changes sign. Then we have the tension in the cable, and again, because we cut the cable here, we have equal and opposite. And then we have the weight from the payload here. Now, the crate. So I called up positive and clockwise positive. So we have that the angular acceleration of this equals the linear acceleration of this divided by this radius here. So alpha equals A over R. So a free body diagram of this, looking at this, we have T minus the weight mg equals ma. Taking a look at this, we have minus T times R plus F times L. I think let's see here, I called this D here, but then I called it L later on. So that should be L. So F times L equals the mass moment times the angular acceleration, and the angular acceleration is A over R. We can basically, do some manipulating here, substitute this into here, and manipulate things. And again, we can we know what M is, we know what T. We can figure out what T is. We can plug it into here, and here we solve for F, and we get F equals JA all over RL plus TR over L. And again, we know what T is from here. I didn't actually write down the value. But if we calculate all this out, we know everything else. And again, T is just, mg plus A. We get that this force here that we need to apply to this crank is 1,300 newtons.